morning, and I'm going to continue the conversation from cloud to another level, cyber physical system, and also talk about the cloud robotics. Try to keep it within 10 minutes limit. This provides a concept map, but also the definition of what is cyber physical system. Starting from here, this is a cyber physical system. There's several components you need to think about. It says cyber physical system is a feedback system that have this many of the different components and need to be real-time, intelligent, distributed, and also human need to be in the loop. If you look at it here, this is CPS, cyber physical system, needed to address the cybersecurity issue. So that's another dimension. If we follow this concept map, there's many research issues needed to be addressed. But I simply do not have enough time. So my focus today will be here, this feedback system. And if you have any cyber security related questions, maybe you can ask David. Cyber physical system is closely related to cloud system. If we say the physical shop floor is at the bottom in the real world, information can be collected and goes to the monitoring mode, and information can be shared in the cloud. So cloud provides the infrastructure for information sharing. And decision making can be made in the cloud by different stakeholders. They share the information, make process a plan, set up a plan, schedule, and so on. Eventually, if those data or decisions stay in the cloud, it doesn't really serve the purpose. It means it goes down to the physical world through the control mode. So everything you made in the last minute will control the devices and make it move in the right way, or first time right. So if I summarize that, we needed to have this closed loop information flow from sensing to monitoring to planning and control, and this loop needed to go on and on. So in terms of a property, cyber physical system is dynamic. If it's dynamic, we need to use adaptive approach to address the dynamic issues. Simply, there's no time to do time-consuming optimization. In the cyber physical system, the traditional tasks may be repositioned. So this picture shows those traditional tasks, some could be put in the cyber world, some other could be put into physical world. So here's my prediction. If we simply draw a line here, the sensing and control still needed to be in the cyber world, in the physical world, whereas as monitoring and planning stuff can be placed somewhere in the cloud or internet-based approach. And there's some similar terminologies around, as you already heard from David. The first presentation, cloud computing. Everyone is using cloud computing. If you have a smartphone, you use a service from somewhere. And there's players around the cloud. And cloud manufacturers put a number of additional players together, but it shouldn't just stay in the cloud. We need hardware in the loop. So the cloud will connect it to the physical world from this cyber physical system. Another illustration is look like this. We can imagine this green trains as a physical machines, equipment. It provides information. That information is just like a vapor, goes up and forms this cloud. And this cloud eventually needed to turn into raindrops and fertilize the physical environment. So that's a closed loop flow. Everything's getting complicated and more complicated. Number of nodes connected together. That's the Internet of Things. Not just the mobile devices, but the physical equipment, machines, robots. It's the Internet of manufacturing things. So if I give a definition about the cloud and the cyber-physical system, my definition would be cloud manufacturing is an integrated cyber-physical system that can provide on-demand manufacturing services digitally and physically to best utilize manufacturing resources. So now I provide some examples to see how cyber-physical system can provide value to you. One example is remote monitoring. Normally we use a camera to do remote monitoring. It contributes to the network congestion. But in this case, perhaps we can use this 3D model to monitor the real environment. And here shows the physical shop floor, and here is somewhere in the cyber world. You still can do the same thing if this model is driven by real-time sensor data. So that's a difference. The cyber-physical system can make internet a real-time application for you. If I just use a camera, I wanted to monitor the same shop floor from thousands of miles away, what happens? You see the image is largely delayed and incontinuous. And if you base on delayed information, how can you do real-time control? It's impossible. But this way, you only need to send very limited data to drive a 3D model, and 3D model is rendered locally. You can do the real-time monitoring and remote control. Second example is remote assembly. In the previous task positioning I mentioned, if we use this internet, use the cloud to do remote planning, remote machining, eventually you need to come down to the remote assembly. There is a need. Even so, this robotic cell can be modeled, but there's an unstructured environment like this component you cannot model in at once. The approach is you put some cameras here and take a few snapshots, and the information sent to the cloud was internet and generate a 3D model. The rest thing you can do is just based on the 3D model to do the assembly without looking at the camera scene. But for comparison, we put a camera image here, and you can see the robot actually mimics the operation of a virtual world. So everything is connected. We can say this is the Internet of Things. We can say it's a cloud robotics, or we can say this is a cyber-physical system. And in this mode, only control code is sent to the robot controller. But when you turn on the camera again, everything is assembled. This is a simple example, but it shows something is capable in the future if we increase the complexity. Another thing, I mentioned the human needed to be in the loop in order to facilitate, contribute to this cyber-physical system. Safety is a major issue. We need to address this issue. Normally, we put a fence around the robot to make the robot safe or make human safe. You can argue from different perspectives. But what happens if we remove the fence? We put a human in the fence, inside the fence. They can play together. And you may recognize this individual, Bernard, sitting here. So he's a brave guy. First, he invaded into robotic cell, and everything working well. So his work mainly is to play with the robot. So from this video, you can see without touching the robot, you can actually manipulate the robot. Robot can sense your demand and try to move robot away, or you can change the configuration, change the safety policy. Robot will follow you. So that's a different strategy you can use. And this way is interruption. If a robot is doing something, you go there, you interrupt the robot operation, robot move away temporarily. But once the environment is safe, is clear, robot will move back and continue what you do. But conventionally, if a human move to the robotic cell, you trigger emergency stop, everything needed to go from beginning again. That's my 10 minutes, almost done. So last two slides, let's just do two very quickly. Human-robot collaboration. So human can be in the center of the loop that we need to remember. automation can never replace a human. And in this mode, human can demand the robot through several ways. You can talk to robot, use sign language to conduct the production of the robotic cell, and also can use another ways, gestures. So all those can combine together without really control the robot using code. You can communicate with the robot. That's the future cyber-physical system as well. So cloud robotics is to use cloud AI, and different robots can share the same wisdom. Thank you very much.